Now this is where things start getting a bit interesting. In this video, we will look at how to generate a command file for a three-dimensional assembly using efficient software. Here I'm using an example from my book Finite Element Analysis using open source software. This example is of a 3D assembly of a plate and a weld. This plate has a cross-section of a solid rectangle with dimension of 100 mm wide and 5 mm thick. It has a 5 mm fillet weld around it. Fixed face on the weld is given a mesh group name of fix, and face on which load of 2000 Newton will be applied, which is on a plate, is given a mesh group name of load. Assembly analysis in CodeEster requires the mesh to have a master and slave pair. A master must have a volume group. It must have a common face with the slave. Master does not need to have a name given for the common face. Master can have other face names for assigning boundary conditions or loads. A slave must have a volume group. It must have a common face with the master. Slave must have that common face named so it is easy to reference it in FE analysis and in command file. Slave can have other faces named for assigning boundary conditions or loads. The connected face in the assembly has to have a name given to it. This is very important for command file and also for CodeEster to perform its analysis. This common face between the weld and plate is given a name f_guide, where f represents that it is a face and _guide represents that it is a guide. One thing to note here is that there should be separate meshes for different parts in the assembly. Here we have a mesh v_weld for weld and v_guide for the plate that is in the assembly. Here V represents that it is a volume and the name after the underscore signifies which volume it is. So let's start generating command file for this analysis. Start efficient if it is not already started. On the mesh type tab, keep everything default as we are going to start a new analysis. We'll leave this as start. For type of mesh, it is med, and for type of calculation, it is linear static. For the analysis type, click on Mechanical 3D Assembly. Once you do that, you will see that information about assembly changes color and it becomes editable now. The first thing that we'll do is that we'll tell what different meshes will be used in this command file. The mesh names are v_weld and we'll give it a logical unit of 20. We'll add this mesh name and number. The second mesh is v_guide with a logical unit of 21. We'll add that mesh as well. The numbers 20 and 21, why are they used is beyond the scope of this video tutorials, and I encourage you to read through the documentation of CodeEster. Once when we have defined what all meshes are there in the analysis, next we need to state the master and slave pair. For master, we need to specify a volume. So here we know that the master is v_weld and the slave has to be a face. Here we know that the common face between the weld and the guide was f_guide. So we add that master and slave by clicking on this button. Please note that all the names used here should be exactly same as that in the mesh. Next we will look at the materials tab. Here we'll give definition of carbon steel material and we'll assign it to all the parts in the assembly. Click on add to add the material definition in. We don't need to define anything for the element type as this assembly does not have any shell or a beam element. For the boundary condition, for type of boundary condition, we'll select the degree of freedom on a mesh group. The boundary condition name is fixed as we did earlier. For is assigned to, we are assigning it to the mesh group fix on weld. As it is fixed, We'll give dx0, dy0, and dz0. We'll add this boundary condition to the command file. Next, we look at the loads tab. For the load name, enter force Z. We will have the load type as force on face. For is assigned to, enter name load. Remember that this name load has to be exactly same as that used in the mesh file. From our previous analysis and from the previous tutorials, we know that 2000 Newton load is applied on 500 square millimeter area. So in here, we'll have to write 2000 divided by 500, which is 4. Add this load to the command file. Next, we'll have a look at output. As I want all the information being present in the results, I'll just click on Add All. I'll click on Save Command File and I'll give it a name, 3D Assembly Analysis.com. I'll save this file. Now let's have a look at the command file. I'll open 3D Assembly Analysis command file and let's have a look at what's the difference. We can see that VWeld has been defined here with a unit of 20. VGuide is defined here with a unit of 21. And then for doing the assembly, this is mesh 1 and this is mesh 2, and we are superposing them. The phenomenon still stays 3D mechanic. The definition of carbon steel material is here. The fixed group is defined here. One interesting thing to see here is that the master-slave pair is shown here. The master is VWeld and the slave is FGuide, as we had defined in Efficient Software. Understanding master-slave pair and how to perform 3D assembly analysis is beyond the scope of this course, but I encourage you to use this command file in finite element analysis of your own.